Hi, this is Mrs. Pearlstein, and this is video number 2 of a 2-part series on special right triangles. Video number 1 dealt with 45, 45, 90 right triangles, and we went through how to find any missing side if you knew one of the other sides. Now we're going to look at 30, 60, 90 right triangles, the other special type of right triangles. So if we look, I drew a quick sketch of a 30, 60, 90 right triangle. And you notice that all 3 of these sides have different lengths. So in order to name them, we have to find a way to differentiate between the 2. So opposite the 30-degree angle is always the smallest or shortest side. So we're going to call that side the short leg. Opposite the 60-degree angle, we're going to call that one the long leg. And the hypotenuse, of course, is opposite the 90 degrees. In order to solve 30, 60, 90 right triangles, you need 2 rules for these because your legs are different lengths. And the 2 rules are that the hypotenuse is equal to 2 times the short leg. So that means if I know the short leg is 3, the hypotenuse is going to be 2 times 3, the hypotenuse is going to be 6. That's rule number 1, that's the easiest of the 2. The second one says that the long leg is equal to the square root of 3 times the short leg. Now those are the only 2 rules, but remember that we can rearrange those and essentially we get 2 more. So let's call this, I don't know, 1 prime. That if I divide both sides by 2, this first equation also becomes that the short leg is equal to the hypotenuse divided by 2. And rearranging the second equation, call that 2 prime, we can see that the short leg is equal to the long leg divided by the square root of 3. So we're going to use those 2 relationships in different ways to find missing sides of a 30, 60, 90 right triangle. So let's look at our first example. $30, $60, $90. It's not drawn to scale. We need to make sure we label them, $30, $60, $90. And I'm going to give you that the short leg has a length of 2, and we need to find the long leg and the hypotenuse. So according to our rules that we just got here, if I know the short leg, all I have to do is multiply by 2, and that will give me the hypotenuse. So y is my hypotenuse, and that's equal to the short leg, which is 2, times 2. So we now know that the hypotenuse is equal to 4. To find the long leg, which is x, we see the long leg is just the square root of 3 times the short leg. So the short leg is 2, and we're going to multiply that times the square root of 3. So our short leg, or our long leg, is equal to 2 times the square root of 3. Okay, that was nice and easy. Sometimes, though, you're going to be given the longer leg. So let's, again, keep this 30, 60, 90 for this one. And let's say we were told that the long leg is equal to 4 times the square root of 3, and we need to find the short leg and the hypotenuse. So go back to our rules, and this time we know the long leg, and so all we would have to do is divide the long leg by the square root of 3, and that would give us the short leg. Or if you just look at this relationship, if the long leg is going to be the square root of 3 times the short leg, then there's the square root of 3, the short leg is going to have to be 4. So 4 root 3 divided by root 3 is just going to be 4. So short leg is 4. You can check yourself. 4 times the square root of 3 gives you the long leg, and there you go, we're back again. And then once you know the short leg, to find the hypotenuse is always 2 times the short leg. So that's going to be 2 times 4, which is 8. Another type of problem is if you are given the hypotenuse and you have to find both the short leg and the long leg. So let's do 30, 60. And so the relationship tells us that the short leg times 2 gives us the hypotenuse. So the hypotenuse divided by 2 is going to give us the short leg. So that's going to be equal to 5. And then once we know the short leg is 5, to find the long leg, which we have y, all we're going to do is take the short leg 5 and multiply it by the square root of 3. And so that's how we take a given hypotenuse and find both of the two legs. All right, so those were nice, neat, even and neat numbers. Let's do one where the numbers aren't so nice. So let's switch up the angles too. Let's say that this is 60 and this is 30. So the hypotenuse, let's say the hypotenuse is equal to the square root of 5. And we need to find both the short leg and the long leg. So according to our rules, our short leg is just the hypotenuse, which is the square root of 5, divided by 2. And so that's it. That's the short leg, square root of 5 divided by 2. Notice, if I take the short leg and multiply by 2, it would just give me the square root of 5, which is the hypotenuse, so that all looks pretty good to me. And then to find the long leg, we're going to take the short leg, which is the square root of 5 over 2, and we're going to multiply that by the square root of 3. So now we have the square root of 5 times the square root of 3, which is the square root of 15 over 2, and that would be the long leg. The last example I'm going to give you is going to be a really important one for us. And we'll do 60 and 30 again. And that's, given a hypotenuse of 1, how do I find the short leg and how do I find the long leg? Well, the process is exactly the same, but we're going to see this situation come up a lot over the next week. So to find the short leg, which is x, all we have to do is take the hypotenuse and divide it by 2. So if the hypotenuse is 1, the short leg is 1 divided by 2. To find the long leg, all we have to do is take the short leg, which we just found to be 1/2, and we're going to multiply that by the square root of 3. So we have 1/2 times the square root of 3, which 1 times the square root of 3 is the square root of 3, all over 2. So those two numbers you're going to see come up over and over again in the future. And so being able to find the two sides given a hypotenuse of 1 is going to be really important. So that's it for 30, 60, 90 right triangles. I hope you understand this because we're going to be using this constantly for the next week. Thanks. Have a great day.